Most people know ketamine, but scientists are exploring a version called R-Ketamine, and it behaves a bit differently in the brain. Today, we'll explore what makes R-Ketamine different, how it works in the brain, and why some scientists think it could be useful in psychiatry. Let's find out. Ketamine contains two mirror image molecules, R-Ketamine and S-ketamine. Until now, most clinical use has focused on esketamine, marketed as Spravato and approved for treatment-resistant depression. But in animal studies, R-ketamine has shown longer-lasting antidepressant effects and possibly fewer side effects than its sibling. Both R and S-ketamine block NMDA receptors, which boosts glutamate signaling and kicks off a chain reaction, more EMPA receptor activity, more BDNF, and ultimately greater brain plasticity. But here's where R-ketamine stands out. It has a weaker grip on NMDA receptors than S-ketamine, which might explain why it causes fewer mind-bending side effects. In animal studies, R-ketamine often shows stronger and longer-lasting antidepressant effects compared to S-ketamine. Researchers think this might be tied not just to BDNF, but also to other pathways like ERK signaling and even changes in the gut microbiome. So while both versions of ketamine kick the brain into reset mode, R-ketamine may do it in a smoother way. Keep in mind, these insights come mainly from animals. Rats and mice give us hints, but human depression is far more complex. One of the biggest downsides of ketamine and S-ketamine is that they can cause dissociation, feeling disconnected from your body or thoughts, and hallucination-like effects that make reality feel distorted. Studies suggest that R-ketamine might cause fewer of these issues, making it potentially easier to tolerate. Animal research also hints that R-ketamine may be less neurotoxic. While S-ketamine triggered certain stress proteins like HSP70 and reduced protective neurons in the brain, R-ketamine did not at antidepressant doses. Again, these findings are mostly from animal studies, so we should be cautious when applying them directly to humans. So, what happens when we move from animals to humans? The human data is still early but interesting. A small study showed a rapid and large drop in depression scores after a single infusion of R-ketamine without strong dissociation. Another study in bipolar depression reported nearly 50% improvement at higher doses, plus a 60% decrease in suicidal thoughts. However, a placebo-controlled study didn't show a clear antidepressant benefit, and a larger company-sponsored trial also failed to meet its primary endpoint. In short, R-ketamine shows potential for longer-lasting, better-tolerated antidepressant effects, but it's still experimental and not yet approved by FDA or EMA. So, is R-ketamine the future of depression treatment? Right now, the hype is strong, but the science is still catching up. Early data suggest it could be longer lasting and better tolerated, but without large-scale clinical trials, we simply can't say for sure. If you enjoy learning about psychology and psychiatry, don't forget to subscribe so you don't miss future videos. And if you'd like to see more about ketamine and S-ketamine, you can find links to my other videos in the description or on my channel. Easy peasy, right?